Hello everyone, in this video I will be talking about the level of measurement and four types of them, which are nominal, ordinal, interval, and ratio. If you are not familiar with these terms or you're still struggling to understand the difference between them, you're in the right company because I will explain it all to you in a few seconds. A bit of a disclaimer, I will be using a few examples involving ice cream in this video, but I am not endorsing ice cream consumption or any specific brand. When we talk about the level of measurement, it is intrinsically linked to another concept, which is a variable. I already have a separate video specifically dedicated to a variable, but as a refresher, I would like to tell you that a variable is a characteristic or an attribute which can vary, as the name suggests. We usually measure it quantitatively because I'm talking about quantitative research and experimental research on this channel. Level of measurement is important because it captures how you measure your variable or concept through your question. And this forms part of your experimental protocol or your survey. And level of measurement applies to answers that you are capturing, how you're measuring the phenomena. And it is super important because it determines statistical data analysis and what you can do with your data and what you cannot do. There are four levels of measurement, and I like to visually summarize them like this table because it becomes very clear what the difference is between each of these levels and how to best remember it. The first level is nominal, then we've got ordinal, we've got interval, and we've got ratio. Wow, that sounds very scary and confusing, but let's break it down because it's super easy. The best way to capture differences between these four levels of measurement is along these four categories. And the first one is that this level of measurement can or cannot capture different categories, whether it can or cannot capture a rank, whether it can or cannot measure distances between your answer options or categories in a meaningful and numerical way, and whether there is or there is not a concept of true zero. As you can see here, as we move from nominal to ratio level of measurements, there are more ticks here in this table. And it also shows you that nominal level of measurement does not have all the ticks. And don't worry, I will go through this table in detail in a few seconds. And ordinal, then incrementally, has more attributes. So does interval, and ratio has ticks across all of these four dimensions. Now, to make it easier to remember, let's first have a look at the nominal level of measurement. Nominal level of measurement is considered to be the most basic level of measurement because of all of them, it can only capture a category. This is why sometimes this level of measurement is also called categorical. Nominal and categorical are used interchangeably by researchers. And it's categorical because it captures a category. So it would be very easy for you to make a mental association and remember the definition. Why is it the most basic level of measurement? Because it captures only distinct categories and they do not have any quantitative value, and it cannot be ranked, and it doesn't have a concept of true zero. This is why here we've got empty blank spaces in this table. Here I have an example of three categories for you, and even if we assign number 1 to blue color, blue ice cream, number 2 to yellow ice cream, and number 3 to our orange ice cream when we're doing research, those numbers do not mean anything. There is no sense of order. And if you move orange to here and blue to here, this does not make something better than the other. It only captures a category. Let's have a look at an example. You may have already guessed that I will be talking about colors as categories in this hypothetical experiment. Let's say after I exposed participants to one of these two treatments, I am asking them which color of ice cream they would like to pick. And I have 5 answer options for them. And they are all captured by numbers, as you can see here on the screen. 1 represents very dark blue ice cream color. then 2 is light blue, 3 is gray, and so on and so forth, and orange is being captured by 5. Now, numbers here do not mean numerical numbers. They are just the numbers to capture a category here, all right? This is why now what I'm saying is that these numbers here, they capture distinctive colors in ice cream choice, which correspond to different ice cream that they pick, but they have no quantitative value. And also, in the experiment, my independent variable has categorical level of measurement because even though 1 represents sad condition and 2 represents happier condition, it's a categorical level of measurement because 1 doesn't mean that it's better than 2 or the other way around. It just captures a category of the treatment that I exposed my participants to. And you can assign a score of 6 or 7 or whatever number you want to it. It does not carry any numerical value. It only captures a category. Let's have a look at other typical examples of a categorical or nominal level of measurement. The choice of a smartphone between Apple, Samsung, Xiaomi or Xiaomi and any other brand, that is a categorical level of measurement. Whether someone has a particular rewards card, yes or no answer categories, also captures categorical or nominal level of measurement. Gender also falls into category of nominal or categorical level of measurement. Why is that? Because again, these numbers which we use just to capture and store our data, they don't have any numerical value. I hope this distinction was clear to you. Let's move on to the next one, which is called ordinal. There is a bit of an order here, an inclination from higher to lower. And keep this in mind because I will explain to you in a second, and it will become super clear why ordinal is called ordinal. Now, as you can see here for ordinal, it does capture a category, but it can be ranked, or the qualities of these answer options, they carry a rank with them and they have a meaningful order, which means something can range from lower to higher. And there is some distance between the answers, but it may not be equal. So it can be ranked. There is some distance between the answers, but it may not be equal or it may be a bit subjective. Now, this may sound super confusing to you, what it means. So let's have a look at an example. Now, here, let's say we are running competition and we have captured records for different participants. And we know that this particular person was the first to finish the race. Then we've got a person who was the second to finish the race, and then the third. Now, there is a sense of a rank, right? A bit of an order from first to third, where first in this case means faster. Second means it's the second after the first one, so it is slower or not as fast as the first one. And then the third one means that it was the third after second and the first. So obviously, there is a bit of an order. It can be ranked. You know that this person is best in this sports performance category. This person is the third. But if you actually translate this one into more meaningful conceptualization, if you do not capture the seconds or minutes with which they finish the race, you actually do not know what is numerical or quantitative nature of a difference between this cat person, this one, and this one. I will show you now examples of ordinal levels of measurement and the questions that are typically used in marketing research, and then you will instantly understand what I'm talking about. Let's have a look at the first example. Let's say this time, instead of a color of the ice cream, I want to measure how many scoops of ice cream they would like to have. So my question for the dependent variable is different here, and I'm asking my participants, how many ice cream scoops would you like to consume today? And they have 4 answer options, and the first one is choice between 1 to 2 scoops, 3 to 4, 5 to 6, 7 or 8. As you can understand from this example, those numbers here, they capture a range from a smaller amount of scoops to a larger amount of scoops. But then because I do not have precision here, I don't know whether it's actually 1 or 2 that they keep. I'm actually measuring a range. It does not carry numerical precision, and I cannot meaningfully measure distances, numerical distance or numerical differences between the groups. And if you try to compute a mean for 1, 2, 3, and 4, you're in big trouble because this mean means nothing. Again, it just captures a category. There's an order, but a mean of 3.5, it doesn't mean that it's 3.5 scoops of ice cream. You actually don't know if it's between 5 to 8 scoops of ice cream. So here you see how this ordinal level of measurement may sometimes lack numerical precision. Let's have a look now at other examples of ordinal levels of measurement, which are frequently used in different questions in marketing discipline. The first one is importance questions, where we measure an importance of a particular attribute, of particular aspect to consumers, and it can range from 1, which is very unimportant, to 10, which is very important. If you want, you can have a scale between 1 to 7, 1 to 5. I just have from 1 to 10 here. And obviously, here, those numbers, they capture a category, and it can be ranked because 1 means not important at all, and then 10 means higher importance. So from 1 to 10 gives you a clear understanding that there is an order from lower importance to higher importance. But why don't we have actually a tick here? Because those numbers, even you subtract them, even if you calculate the mean, they do not carry 100% pure numerical specificity because this is a subjective rating. What is 2 to me on this scale from 1 to 10? Maybe actually 3 to someone else. So as you can see here, with this ordinal level of measurement, there is a lot of subjectivity that consumers bring in with their own perceptions of reality. Now you may say, well, I see all the time in marketing research reports that means are calculated for ordinal levels of measurement. Yes, that's true. Marketing researchers very often do that. But what some other market research companies do, they calculate top 3 boxes and the bottom 3 boxes and percentages, or they actually provide percentages for all scores. So keep this in mind. There is a big debate whether you can compute mean or you cannot compute mean for ordinal levels of measurement. In a lot of academic papers, you will see that means is being calculated and computed. If you go and you work for market research industry, you will see a slightly different trend where top 2 boxes or top 3 boxes, bottom 3 boxes, or bottom 2 boxes are computed and they just capture percentages, because then they provide greater specificity in terms of what's going on in your data. Other examples of ordinal scales so frequently used in marketing research are Likert scales, which are agreement, how strongly you agree or disagree with something. Again, you will see very frequently how means are computed for questions like this, but in applied marketing research, if you go and work for industry, you'll see that sometimes companies compute bottom 2 boxes, so they compute percentages for answer option 1 and 2, for 3 separately, and also for 5 and 4, which is referred to as top 2 boxes, because some of them do not want to report means because they may not be very realistic of true numerical representations in your data. Satisfaction questions, again, they are ordinal because it shows that there is lower satisfaction, high satisfaction, again, sense of order, and it can be ranked. And in purchase intentions, how likely or unlikely you are to purchase something, so frequently used in marketing research and experiments. Again, it is an ordinal level of measurement, and the actual numerical distances are not 100% meaningful. Now let's move on to the interval level of measurement. As you can see here, we have a tick in the third category, which is distances between the categories are meaningful and can be measured, but there is no true zero. That's why here I have a ruler for you. So when you think about interval level of measurement, try to think of more numerically meaningful intervals to remember the difference between this level of measurement and the other ones which I have covered already in this video. So why interval level of measurement has a tick here? It is considered to be a more precise level of measurement, and distances between answer categories are now actually meaningful, and it does capture categories and it can be ranked. But here we can, with more assurance, compute numerical differences between different answer categories, and we can easily say or quantify the difference between one consumer and the other one. Let's have a look at an example. Again, I will use an example of my experiment. This time, let's say I actually want to measure how many scoops of ice cream they would like to consume in a more specific and precise numerical way. And as you can see here, my answer options range from 1 and 5. And 1 corresponds to 1 scoop, 2 to 2, 3 to 4, and so on and so forth. So here, if one person who was allocated to the set condition group picks 5 scoops and a person who was allocated to happy condition picks 1 scoop, subtracting 5 from 1 gives me 4 scoops. And that quantitative difference between the persons is meaningful. So here, as you can see, it captures the order from smaller amount of ice cream consumed to a larger one, but this time we can compute a mean, and the differences between answer options are meaningful, and they do have a lot of numerical specificity and precision. Now, other examples of interval level of measurement include IQ, IELTS tests, GMAT, GRE, TOEFL tests, which are used to measure someone's ability in a particular discipline, the weight and the mass, duration of something in seconds or minutes. And it can be discrete, so you can have a whole number, for example, 7, or it can be continuous and you have IELTS score of 7.5 with a decimal point. Let's have a look at the ratio level of measurement. It has all the attributes of interval level of measurement, but here we have a concept of true zero, which means that the answer categories in the experiment that you are running may include 0 as an answer. To give you an example, and to make it very clear to you, if some consumers in my experiment would say, I would select 0 scoops, I just don't feel like eating ice cream today at all, then from interval level of measurement, you are transitioning into ratio level of measurement because 0 becomes a possible answer option. Let's have a look at other examples of ratio level of measurement. If you're doing research on tourism, you may ask people how many days they spend in a particular resort. If 0 is a possible answer option, you're dealing with a ratio level of measurement. How many cars does your household have? If 0 is a possible answer option, people don't have a car, they commute using public transport, it is a ratio level of measurement. How old are you? It can be in 0 years if this is a possible answer option. On average day, how much do you spend on eating out? If you don't eat out a lot, then 0 is a possible answer option. And again, very similar to the interval level of measurement, you can be dealing with discrete whole numbers. For example, 0, 1 car. You cannot have 1.5 cars. Or it can be continuous, just like here, because here you can measure with numerical precision the equivalent of amount of money people spend, including cents. Why level of measurement is important in experimental research? Well, it's because it is linked to how you will be analyzing your data. Let's have a look at it. Here, I first make a distinction between subject experiments and also within subject experiments. In the first column, I have an experimental independent variable, and I'm assuming it is nominal because this is most typically the case in experimental research. We measure our treatment or we capture our treatment as a nominal variable. Only if your treatment has a true numerical value, for example, a temperature, and you have multiple amount of experimental conditions with different temperature variations, and you, let's say, measure some differences in consumer discomfort, then it is interval level of measurement. But here I am using nominal level of measurement as it's the most typical one in experimental research. What's important and has implications for your data analysis is for you to understand how many number of treatments you have. And this is what's captured by N, number of experimental treatments. And as you can see here, I have 1 or more treatments, 2, 3 or more. And then I have the dependent variable and how the dependent variable is measured. Then I also have your data distribution, whether it's parametric or non-parametric, and the aim of the test. So let's say you are dealing with one or more levels of treatment in your independent variable, and your dependent variable has nominal or ordinal level of measurement. If you want to see whether there are any differences in percentages in answer options in your nominal level of measurement, and sometimes researchers do that for ordinal level of measurement when they do not want to compute means, the best test is a chi-square test for you, all right? When you have two treatments and you are dealing with ordinal interval or ratio level of measurement for your dependent variable, and your data is normally distributed, you will be dealing with independent sample t-test. If your data is not normally distributed, you'll be dealing with Mann-Whitney u-test. And what you're doing here, you are testing differences in means between two treatment groups. You're not testing differences in percentages. If you want percentages, you will be doing a chi-square test, all right? Now, if you have three or more treatment groups and your dependent level of measurement is, again, ordinal, interval, or ratio, you need to use ANOVA, analysis of variance, if your data is normally distributed. If it's not, please use Kruskal-Wallis test. And here, you are testing mean differences between three or more treatment groups. Okay, let's have a look now at the scenarios where we are looking at within subject experiments, where we are measuring something before and after, let's say, to see whether the attitude, perceptions, or behavior changes based on our intervention. Here, my table is slightly different. I am assuming, for the sake of this example, that the level of measurement is nominal. And here in the second column, I have the number of treatments in independent variable. Then I have the level of measurement for the dependent variable. And I am using ordinal, interval, and ratio across all of these examples, okay? Then I have parametric and non-parametric distribution and the aim of the test. So as you can see here, if we have one treatment group, which means you have only one group of consumers, you are executing a treatment. But before you executing, you measuring knowledge, attitudes, perceptions, or behavior, and then you are doing exactly the same thing after you expose them to your treatment. This is called one-way repeated measures. And if your data is normally distributed, you will be using paired sample t-test. If your data is not normally distributed, you will be using k-related samples, and it's called Friedman test. If you're not sure how to run it, here's explanation and a very good resource on how to run it in SPSS. And the aim of this test is to see whether there are any differences in means within the same treatment group. Let's say now you have that treatment group and another group which received a slightly different treatment. This means you have two groups and you're looking at a two-way repeated measure. If your data is normally distributed, you can use general linear model repeated measures. I know the name is pretty scary and long, but it's available on SPSS and it's an amazing tool to do data analysis. The visualization of your data is fantastic and you can see how something moves. It's a really, really overlooked method to analyze your data, and I encourage you to have a look at it because it's a very powerful tool and you can get a lot out of it. If your data is not normally distributed, you need to use Wilson sign rank test. And what you're doing here, you're looking at differences in mean within one group, but also between the two treatment groups. It's, like I said, it's a very powerful tool because you're trying to see what's the extent of change within one group, but also between those groups. Where is the change actually greater? If you have three groups or more as part of your treatment, you're looking at three-way repeated measures. Never ran this experiment before. I've done this one, but the logic is exactly the same. You would be using general linear model repeated measures available in SPSS. But here, based on my research, and if you found some other information, please put the comment down below, let me know. I found that it requires custom R script, and I couldn't find an alternative for SPSS. The purpose of this test is, again, to see whether there are any statistically significant differences within the same group and also between those three groups. Are we done? No, not yet, because as a brain teaser, I have a reflection task for you. I want you to guess the level of measurement of income before tax. As you can see, I have three versions here. I want you to reflect on what you've heard in this video and then put down below in comments which level of measurement you think corresponds to each of the versions. In the first one, the answer options are I have no income, captured by answer option 1. Second, have some income, 3, prefer not to answer. In version 3, you can see that I have answer options 1 to 7, where 7 is prefer not to answer, and then I've got ranges here under 20,000 and then 20,000 and 1 to 40,000 and so on and so forth. And the last one, I'm asking people to type in, what is your household income before tax? Please type in. What level of measurement is that? Now, I hope you found this video, despite its technical complexity, entertaining and insightful, that now you can easily tell the difference between different types of questions, how data is captured, and what level of measurement the data that you are collecting corresponds to. You're empowered now and you are ready to run your experiments.